I was asked to go over this question. There's actually 3 questions here, getting harder as we go along. This first one for number 18 is actually the easiest one. And what you have to remember when you're looking at this, when it says, how do you know what value of C is going to give you 2 distinct roots, equal roots, and no real roots? You have to remember what a parabola looks like if the equation it represents has 2 x-intercepts, only 1 x-intercept, and no x-intercepts. So first thing you remember is that if x squared plus c equals 0, what I'm really trying to do is figure out where y equals x squared plus c crosses the x-axis. So y equals x squared looks like this. Excuse me. And we just have to know what the c does, which is going to move it either up or down, to give it different values of x-intercepts. So for the first one, 2 distinct real roots means that it has to cross twice. Right now, it's just sitting on the x-axis, so it only has 1 distinct root, which is the same as saying it has 2 equal roots. So currently, with no c on there, or in other words, a c of equal to 0, we're satisfying this b equation. Now, if I move it down, then it will cross the x-axis twice. Now, a downward movement is the same as having c be less than 0. In other words, a negative value. So if I want to give c a negative value, or say it's less than 0, that's going to move it down and give it 2 distinct roots. And opposite to that, if I move it up, in which case c will have a positive value, which is greater than 0, then I'm going to get this case where there's no real roots. So c is greater than 0. Now the biggest thing here is the part that moves it up and down is what's going to give it the roots. Moving it left and right doesn't give it any roots. It just determines where it's going to be. So when we get to this question over here, which is a little bit more complicated, we don't know what moves it up and down because this isn't in the right form. This is in the form, this is in standard form, and we need it to be in completed square or vertex form to be able to do it. So what we have to do here is complete the square. So the parabola I'm looking to figure out whether it's going to cross the axis is y equals x squared plus 14x plus c. And now I'm going to go about the process of completing the square. Put the brackets around the first 2 terms. If there was something in front of here, I would divide it out, but there isn't. So I'm just going to jump down a couple of lines, and I know that this has to be x plus 7. And that goes way too big. X plus 7 in the brackets because I divide by 2. And now I have to square it to get what goes back up here. So x squared plus 14x plus 49. And then there's a minus 49 in there. And then there's this plus c on the end. And now I have to take this out of the brackets. So we go x squared plus 14x plus 49. And then out of the brackets, it's minus 49 plus c. Now, these 2 things can't go together. It's just minus 49 plus c. And this is the term that I have to know whether it's going to move the parabola up, down, or leave it on the x-intercept. So currently my parabola looks like it's right side up, and I just have to make it, and it's backwards 7 spaces. So the vertex is over on this line somewhere, and I just have to know what value of c is going to put it up here, here, or down here. Now, if c is positive, it's going to be up here. If c is 0, it's going to be here, and if c is negative, it's going to be down here. So the 0 is the easiest. If I, well, and shoot, I shouldn't have said c. I should have said this constant term is positive negative. So this 49 figures it into it. So in order to get it right on the axis, this whole constant term has to be 0. So negative 49 plus C has to equal 0, means that C has to equal 49. And if it's right on the axis, that means it has only one root, or mathematicians are kind of weird about this. They say it actually has two, they're just exactly the same. So they're two equal roots. So if C is equal to 49, then we know that they're going to have equal roots. Now, if this term here is positive, negative 49 plus C, if that's positive, which means greater than 0, okay, it's going to move it up. So if I take a look, how is this going to be positive? Well, C is going to have to be a number bigger than 49 in order to cancel out all these negatives. So, and when it moves it up, it has no real roots. So that's this case. So C is going to have to be bigger than 49 in order to move it up and have no real roots. And if I move it down, then it's eventually going to cross the x-axis in two spots. So if negative 49 plus C is negative, less than 0, then it's going to have two distinct roots across the x-axis twice. But if we take a look at this, how do I keep this to be a negative number? Well, as long as C is less than 49, if it was 48, negative 49 plus 48 is negative 1, making it a negative answer. So anything where C is less than 49, not 99, 49, it's going to give us two distinct roots. Now, the next one you're going to do exactly the same way. You'll have to complete the square first. I'm going to leave this one up to you to give it a try. This one's a little bit harder because when I divide by 2 and square it, I'm going to have b's, not numbers. But to divide b by 2, you go b divided by 2. And to square this, you square the top and then square the bottom. So you get b squared over 4. Try to give that one a go yourself. And we'll leave it at that.